This video is about the electrolysis of a very dilute sodium chloride solution and a concentrated sodium chloride solution respectively, using graphite electrodes. Let us first consider the electrolysis of a very dilute sodium chloride solution. When sodium chloride dissolves in water, it dissociates to give sodium ions and chloride ions. Water slightly ionizes to give hydrogen ions and hydroxide ions. Hence, there are 4 types of mobile ions in a very dilute sodium chloride solution. There are 2 graphite electrodes in this setup. The graphite electrode connected to the positive terminal of the dry cells carries a positive charge. The one that is connected to the negative terminal carries a negative charge. The positively charged graphite electrode attracts anions in the solution, and it is the anode of the electrolytic cell. The negatively charged graphite electrode attracts cations in the solution, and it is the cathode of the electrolytic cell. During electrolysis, sodium ions and hydrogen ions would migrate towards the cathode, while chloride ions and hydroxide ions would migrate towards the anode. Usually, one type of cation and one type of anion are discharged before the others. In this example, which type of ion is preferentially discharged at the cathode? Since a hydrogen ion is lower than a sodium ion in the electrochemical series, it is reduced more readily than a sodium ion. Therefore, hydrogen ions are preferentially discharged at the cathode to form hydrogen gas. After the discharge, water ionizes to replace the hydrogen ions discharged at the cathode. Now think about which ion is preferentially discharged at the anode. Since the hydroxide ion is higher than the chloride ion in the electrochemical series, it is oxidized more readily. Therefore, hydroxide ions are preferentially discharged at the anode to form oxygen gas. After the discharge, water ionizes to replace the hydroxide ions discharged at the anode. Now combine the 2 half equations to get the overall equation for the reaction. As you can see, the electrolysis of a very dilute sodium chloride solution can be considered as the electrolysis of water. As electrolysis continues, water is decomposed. The sodium chloride solution gradually becomes more concentrated. However, the electrolysis would give different products if a concentrated sodium chloride solution is used instead. There are 4 types of ions in a concentrated sodium chloride solution, but the concentration of sodium ions is much higher than that of hydrogen ions. Similarly, the concentration of chloride ions is much higher than that of hydroxide ions. Sodium ions and hydrogen ions would migrate towards the cathode, while chloride ions and hydroxide ions would migrate towards the anode. Due to this concentration effect, chloride ions are preferentially discharged to form chlorine gas at the anode. At the cathode, although the concentration of sodium ions is much higher than that of hydrogen ions, their positions in the electrochemical series are very far apart. Hence, hydrogen ions are preferentially discharged. Combine the 2 half equations to get the overall equation for the reaction. As electrolysis continues, hydrogen ions and chloride ions are continuously consumed, while sodium ions and hydroxide ions remain. Therefore, the sodium chloride solution gradually becomes alkaline.